Way 76 deals with kinetics and equilibrium, and it specifically deals with the heat of a reaction. We say that a reaction is exothermic when it releases heat, meaning that energy in a chemical equation appears on the right side of the arrow. We say a reaction is endothermic if heat is absorbed and energy appears on the left side of the arrow. In general, when we're talking about entropy, which is represented by the amount of disorder present in a particular state, we say that entropy increases as we go from solid to liquid to gas. And that's in part due to the array of particles as a solid transitioning to a liquid, transitioning to a gas. As a solid, the particles are more compact and ordered. As we melt the substance, it becomes more random and chaotic as the particles move between each other, but they haven't quite escaped into a gas, in which point at which point they become the most chaotic. So entropy increases in this direction and entropy decreases in the reverse direction. So remember, when it comes to exothermic, heat is being released, energy is on the right. Endothermic, heat is being absorbed, energy is on the left, and entropy increases as we go from solid to liquid to gas. So let's use this idea to solve some Regents problems. Nitrogen dioxide is a dark brown gas that is used to make nitric acid and to bleach flour. Nitrogen dioxide has a boiling point of 294 Kelvin at 101.3 kilopascals. In a rigid cylinder with a movable piston, nitrogen dioxide can be in equilibrium with colorless dinitrogen tetroxide N2O4. This equilibrium is represented by the equation below. 2 nitrogen dioxide gas is in equilibrium with dinitrogen tetroxide plus 58 kilojoules. State evidence from the equation that the forward reaction is exothermic. So, what can we identify from this reaction that shows that the forward reaction, going from left to right, is exothermic? Remember, exothermic means that energy is being released and energy should be on the right side of the equation. So all you could say is that there are 58 kilojoules of energy produced by the forward reaction. You could also simply state that the heat term, represented by 58 kilojoules of energy, is on the right side of the equation. Either one of these is acceptable. Given the balanced equation representing a reaction, which statement describes this reaction? Notice this question is asking you about bonds forming and breaking, so you should be remembering barf, break, absorb, release, form, and to classify this reaction as endo or exothermic. Note that energy is on the left side, so the reaction is endothermic, so it's between answer choices 1 and 3. Now, in this case, are we forming bonds or are we breaking bonds? Well, here this 2 means that nitrogen is together and bonded to one another, and here the product nitrogen is separate. So that means bonds are being broken, so answer choice 1 is correct. Bonds are broken and the reaction is endothermic. At standard pressure, hydrogen peroxide H2O2 melts at negative 0.4 degrees Celsius, boils at 151 degrees Celsius, and is very soluble in water. A bottle of aqueous hydrogen peroxide H2O2 aqueous purchased from a pharmacy has a pressure releasing cap. Aqueous hydrogen peroxide decomposes at room temperature as represented by the balanced equation below. 2H2O aqueous yields 2H2O plus O2 plus 196 kilojoules. State evidence that indicates the decomposition of H2O2 is exothermic. To classify this as exothermic, we need to spot where energy is located, and notice that here energy, represented by 196 kilojoules, is on the right side of the arrow. So all we have to say is that more energy is released than absorbed, or we could just say that heat is a product of the reaction, or energy is a product of the reaction as opposed to a reactant. If that were the case, it would be endothermic. But in this case, it's exothermic because energy is being released. Okay, so when it comes to exo and endothermic reactions, note that exothermic reactions means energy is being released and energy is a product. If it's an endothermic reaction, energy is being absorbed and energy is a reactant. When it asked to classify entropy, in general, it increases from solid to liquid to gas and decreases in the reverse direction. Hopefully, this was helpful and thank you for watching.